Hi guys, in this video we're going to have a look at similar shapes, and we're just going to concentrate on comparing lengths in this video. So in part 1 I'm going to concentrate on the lengths, and then in part 2 it's going to look at area and volume. So in this particular one, as I say, we're just going to look at lengths. Now the first thing with similar shapes, and the question in the exam will always tell you that the two shapes are similar, and that tells you that all of the angles are the same. Okay, so for example, this angle here will be the same as this angle here, and that angle will be the same as that one, and so on and so forth. So all of the angles are the same, but the shapes are just enlargements of each other. Okay, so this one here is obviously going to be smaller because this side is 6, this side is 12, this one is smaller than this one, but it's just an enlargement. Okay, so all the angles are the same, it's just an enlargement. And as you might know from dealing with enlargements with transformations, you need to know what the scale factor is. And there's no difference here, we still need to know what the scale factor is. So what I'm going to do first is I'm going to put a little note down here. I'm going to put the length scale factor, because that's what I need to know. I need to know how many times bigger this shape is compared to this one. So that's also what I'm going to write down. I'm going to say this is the small one and this is the big one. Okay, because I say this side here is 6, the same side on the big shape is 12, so small, big. And that is what we need to do to work out the scale factor. We look at two sides that are the same. So this one here is 8, that's an X, so I can't compare them. That's Y, that's 5, so I can't compare them. This one hasn't got nothing, this one's got nothing, so again I can't compare them. The only two sides that I know is the 6 and the 12. So they're the ones that I look at, and they're the ones that are going to tell me my scale factor. So what I would do is I'll just make a little note, so small, and how do I go from the small shape to the big shape? Well, the small value has a 6 and the big value has a 12. So how do I go from 6 to 12? You might already be ahead of me. I times by 2. The scale factor, or the length scale factor I should say, is 2. So to go from small to big, I times by 2, and then to go backwards, big to small, I do the opposite and I divide by 2. Okay, so that's what I need to use to then work out my X value and my Y value. So I use this scale factor that is twice as big. So to go from small, so 8, to the corresponding side here, X, I'm going from small to big. So I use this, small to big, I'm going to times it by 2. So 8 times 2 is 16. I should put my units of centimetres. So X there would be 16 centimetres because I just times that by 2. Now, to work out Y, I'm going from big to small. So from big to small, I need to divide by 2. So 5 divided by 2 will obviously give me 2.5 or 2.5, and again centimetres. So that's why I always do this, the small and the big, times and then divide. Just helps you when you're comparing these lengths here in the diagram. But the key thing of this whole question is getting that scale factor. And of course remember, the angles are all the same. In the exam, lots of people get it wrong, so they actually use the scale factor with the angles as well. It's completely wrong. The angles stay the same. It's only the sides that get bigger or smaller. So let's have a look at this one. Exactly the same thing. I need to work out the length scale factor. So I'm going to make a quick note of that, tell the examiner what I'm doing. And again, I'm looking at this shape here. I can't compare those ones, can't compare those sides, but I do know these sides. So I'm going to go same thing, small, which is this shape, because 4 is smaller than 6. So small, and this one's the big. And again, the small length there is 4, big length is 6. How do I go from the small to the big? Now you might be able to spot that it's 1.5, but if you can't, the way to figure it out is to do the big one divided by the small one. So 6 divided by 4, which would be 3 over 2, which as I said is 1.5. So I times by 1.5, because that's the scale factor, so times to get it from small to big, and then I divide by 1.5 to go from big to small. Okay, so that's how you can work out the scale factor if it's not quite as obvious as twice as big. Just take the big value, divide it by the small value, and then you can work out what that scale factor is. Once you've got that, you can then apply it to the rest of them. So again, this side here is 12. The corresponding side on the big shape is x. That's what I need to work out. So to go from small to big, I times by 1.5. So 12 times 1.5, that will give me 18 centimetres again. Okay. And next one here is y. So I look at the corresponding side. On the big shape, it's 15. I'm going to the little one here. So big to small, I divide by 1.5. So 15 divided by 1.5, and that's going to give me 10 centimetres. Okay. Excellent. So that's the basics of it. Let's have a look at some slightly trickier questions. So swap this over. Bear with me a second. Excellent. Okay, so this one here, 2 points I'm making with this one here. One is that the other way round. What some people do is always go from this one to this one because they think 9 times out of 10 it's fine because this shape is usually smaller, on this side it's usually the bigger. But in this case I've swapped them around just to illustrate this point. So be careful and make sure you do just label them correctly. Okay, so this is the small one. When I compare these two sides that I know, so I've got 5 and 3, this is clearly the small, this is clearly the big, so be careful with that. And the rest of it is exactly the same. I still want to find the length scale factor. I'm still going to have my small shape, and I'm still going to have my big shape. And the small shape, the sides that I'm comparing is the 5 and the 3, so I have my 3, and I have my 5. And how do I go from small to big? So again, that's not entirely obvious. So I'm going to do that trick of 5 divided by 3. Now I'm just going to show you something here, because this is where people have made mistakes before. If you do 5 divided by 3, as a decimal, it's 1.6 recurring. So what people do is they round it, or they just call it 1.6. They don't spot it's recurring. If you round it, or just call it 1.6 or whatever, you will get the wrong answer because it's recurring. You need to use the whole thing. The easy way to get over this is just to keep it as a fraction. There you go, you can see it recurring there. If you just keep it as 5 over 3, you'll get the right answer. So in this case, I'm just going to have the scale factor as a fraction and call it 5 over 3. So to go from small to big, I'm going to times by 5 over 3. And to go from big to small, I'm going to divide by 5 over 3. Okay? So let's apply that to our question here. I need to work out x, so I'm going from small to big, so I times by 5 over 3. So the small one is 6, I've got 6. I'm going to times that, I'm going to use my fraction button here and go 5 over 3, press equals, and I get 10. So I'll just write that on here, 6 times 5 over 3 equals 10, and what the units here, centimetres again. Okay, so whenever you have a recurring decimal like that, don't use that recurring decimal because you're likely to make a mistake. Just use the fraction. And the last sort of question that you could see is when you have a shape like this where they say it's similar. Okay, so you've got a small triangle inside a big triangle. First thing that you should always do is just do 2 quick sketches of the 2 triangles separately. It makes it so much easier. So that's what I'm going to do very quickly up here. Doesn't have to be fancy. So this is the little one. So A, B, C. That length there is 15 centimetres. That length there is 12.5 centimetres. And then the slightly bigger triangle. So it doesn't have to be posh. It's just to make it easier to see what's going on. And this side here will be 15 plus the 6, so that will be 21. Again, it's centimetres. We're after that length there, x. Excellent. Okay, so the first thing to do is, there's the little one, and obviously the big one. Just redrawn them, just quick sketch, just to make it a bit clearer, like these ones up here. Again, I'm going to put small and big to help me, because I'm going to compare these two sides here, like 15 and 21. They're the ones that I've been given. So here we go. Let's go small, big. The small was 15 and the big was 21. So how do I go from big to small? What do I times by? In other words, I need to find out my scale factor. And again, might be a bit unsure, so do the old 21 divided by 15, big divided by small. So you could simplify that fraction and go and use that, it's not a problem. Or if you've got a calculator, 21 divided by 15, you're going to get 7 over 5 if you were to simplify it, or 1.4. So the scale factor here is 1.4. And then obviously to go back from big to small, we divide by 1.4. Again, you can use the fraction as we did up here, it's not a problem. So I want x, so I'm going from small to big. So 12.5 is the small one. Going to big, small to big, we times by 1.5. So 12.5 times by the scale factor of 1.4. Let's just have a look what that is. 12.5 times 1.4 gives me 17.5, and again centimeters. Okay, so with similar shapes, it's all about finding the scale factor, and then going from small to big, you times by it, big to small, you divide by it. Hopefully that helps, guys. Cheers for watching.